What defines dominance on the battlefield? Is it firepower, agility, survivability, or a blend of all three? For decades, the AH-64 Apache has answered that question with unrivaled precision and force. This legendary helicopter, with its sleek silhouette and devastating arsenal, has earned its place as the most feared weapon in the skies. Let's take a journey through the Apache's story. The birth of the Apache. In 1972, the Army faced a setback when the ambitious AH-56 Cheyenne helicopter program was canceled. The Army's dream of a cutting-edge anti-armor attack helicopter seemed out of reach, especially as attention shifted to other projects like the U.S. Air Force's A-10 Thunderbolt II and the Marine Corps' AV-8A Harrier. Yet the Army wasn't about to give up. They wanted a machine that could outshine the AH-1 Cobra in firepower, range, and performance, and they wanted it under their command. Here's the twist. Under the 1948 Key West Agreement, the Army was forbidden from operating combat fixed-wing aircraft. So, their solution? A helicopter that could dominate the battlefield with deadly precision, even while flying low and fast, hugging the terrain in nap-of-the-earth maneuvers. On November 15, 1972, the Army took action, issuing a request for proposals for what they called the Advanced Attack Helicopter Program. This wasn't just any project, it was one of the Army's most critical endeavors. By September 1973, the AAH was officially designated as one of the Army's Big Five modernization priorities, alongside game-changing systems like the Abrams tank and the Patriot missile. The competition heats up. When the RFP went out, 5 aviation giants entered the fray: Bell, Boeing Vertol, Grumman, Hughes Aircraft, Lockheed, and Sikorsky. After much deliberation, the Department of Defense selected Bell and Hughes as finalists in July 1973, starting off the first phase of the competition. Both companies were tasked with building prototype helicopters and putting them through rigorous flight tests. Hughes unveiled its Model 77, later called the YAH-64A, and Bell countered with its Model 409, or YAH-63A. The stakes couldn't have been higher. Hughes's YAH-64A took its maiden flight on September 30, 1975, followed closely by Bell's YAH-63A on October 1, 1975, just one day apart. The Army evaluated both designs meticulously. Ultimately, in 1976, Hughes emerged victorious. The YAH-64A was chosen over Bell's YAH-63A for a few key reasons: its robust, damage-tolerant four-blade rotor system and the superior stability provided by its landing gear design. Bell's YAH-63A, with its tricycle landing gear, just couldn't measure up. Building the beast. With Hughes now leading the charge, the AH-64A entered Phase 2 of development. The plan was ambitious: build 3 pre-production AH-64s and upgrade the existing 2 YAH-64A prototypes and 1 ground test unit to match. This phase focused on integrating cutting-edge weapons and sensors, and it was during this time that the helicopter became a true tank killer. A pivotal moment came with the introduction of the AGM-114 Hellfire missile, a laser-guided weapon specifically designed to destroy heavily armored targets. Development of the Hellfire began in 1974, with its name standing for Helicopter Launched Fire and Forget Missile, later simplified to Hellfire. This missile would become the Apache's deadliest weapon, giving it the power to take on any battlefield challenge. The rise of the Apache. By 1981, the AH-64 Apache was proving itself to be a revolutionary helicopter. 3 pre-production AH-64s were handed over to the U.S. Army for Operational Test 2, a critical phase in determining whether this cutting-edge machine was ready for the battlefield. The results were promising. The Apache performed brilliantly during testing. However, the Army decided it needed even more power, opting to upgrade the helicopter with the General Electric T-700-GE-701 engine, capable of producing 1,690 shaft horsepower. It was also in late 1981 that the AH-64 received its iconic name, Apache, honoring the fierce and resourceful Native American tribe in keeping with the Army's tradition of naming helicopters after Native American tribes. The Apache was officially approved for full-scale production the following year in 1982, marking the beginning of its journey to become one of the most formidable weapons in military aviation, rolling off the line. In 1983, the first production AH-64A helicopter rolled out of the Hughes Helicopters facility in Mesa, Arizona. This marked a major milestone for the program, but big changes were on the horizon. In 1984, Hughes Helicopters was purchased by McDonnell Douglas for $470 million. The Apache's development would soon be guided by one of the biggest names in aerospace. Later, in August 1997, McDonnell Douglas merged with Boeing, and the helicopter unit became part of the Boeing Company. This move solidified the Apache's future under the leadership of an aerospace giant that would continue to refine and produce the aircraft for decades to come. The costs of perfection. By 1986, the Apache was fully operational, but the journey to perfection wasn't without challenges. At the time, the incremental or flyaway cost of an AH-64A was $7 million, while the average unit cost, including all associated expenses, was closer to $13.9 million. The Apache was an expensive but critical investment for the Army. However, not everything went smoothly. The 1985 Department of Defense Engineering analysis, conducted by the Inspector General's office, revealed significant design deficiencies that still needed fixing. Army Project Manager Colonel William H. Forster identified 101 action items that required attention. One major issue involved the helicopter's 22-foot-long main rotor blades, which were crafted from a combination of steel and composite materials to balance strength and weight. Manufactured by the Composite Structures Division of Alcoa Composites, these rotors initially fell far short of the Army's expectations for durability. Instead of lasting the required 1,500 flight hours, the blades needed replacement after just 146 hours of use. It took 6 design changes over several years to resolve the problem. By early 1991, the rotor blade lifespan had been extended to 1,400 hours, a vast improvement that cemented the Apache's reliability in combat. The journey to the Apache longbow and beyond. The AH-64 Apache was already an impressive machine in the 1980s, but engineers and military planners knew it could be even better. McDonnell Douglas began exploring an upgraded version called the AH-64B, which featured an improved cockpit, an updated fire control system, and other advancements. However, by 1988, the Army decided to aim even higher. A multi-stage upgrade program was approved to enhance the Apache's sensors and weapon systems, but technological advancements soon made these plans feel outdated. In August 1990, the Defense Acquisition Board greenlit a bold new path: the development of the AH-64D Apache longbow, a game-changing version of the helicopter that would redefine battlefield dominance. Birth of the Apache longbow. The first AH-64D Apache longbow prototype took to the skies on the 15th of April 1992, marking the start of a new era for the Apache. Prototype testing ran until April 1995, during which 6 AH-64Ds faced off against a larger group of AH-64As in a series of rigorous evaluations. The results were staggering. The AH-64D demonstrated a 7-fold increase in survivability and a 4-fold increase in lethality compared to its predecessor. With such clear advantages, the Apache longbow was fast-tracked into production. On the 13th of October 1995, full-scale production was approved. Less than a year later, in August 1996, the Army signed a $1.9 billion 5-year contract to upgrade 232 AH-64As to the new AH-64D standard. The first production, AH-64D, flew on 17 March 1997 and was officially delivered on 31 March 1997. Building the Apache. While Boeing oversaw Apache production, the project involved a network of aerospace companies from around the world. Augusta Westland manufactured key components for the international market, including the British Army's Augusta-Westland Apache. In 2004, Korea Aerospace Industries became the sole producer of Apache fuselages, taking over from Teledyne Ryan Aeronautical. The transition wasn't without drama. Boeing and Teledyne Ryan became embroiled in a legal battle over the transfer of fuselage production, sparking a prolonged dispute: the cost of modernization. By 2007, the AH-64D program had cost a staggering $11 billion, reflecting the complexity and ambition of the project. Modernization efforts continued into the 2000s. In April 2006, Boeing secured a $67.6 million fixed-price contract to remanufacture several existing AH-64s, as into the AH-64D configuration. Between 2009 and 2011, 5 additional contracts were awarded to convert more AH-64As into AH-64Ds, ensuring older Apaches stayed combat-ready. By 2008, nations operating older Apache models were urged to modernize, as support for the AH-64A was being gradually phased out. This push for modernization reinforced the Apache's status as a cutting-edge platform that could adapt to evolving battlefield needs. Designed for agility and survival, the Apache isn't just powerful, it's agile. Equipped with 2 turboshaft engines and a 4-blade main rotor, it's designed to thrive in diverse environments, from urban jungles to dense forests and mountainous terrain. The helicopter's advanced avionics and digital autopilot systems make piloting it smoother and more effective, minimizing the need for constant manual input. This agility isn't just about flying, it's also about logistics. Unlike many helicopters that require partial disassembly for transport, the Apache can have its rotor blades folded and fit snugly into a military cargo jet like the C-17 Globemaster III, cutting down preparation and transport time significantly. Looking to the future, even as the AH-64D became the backbone of attack helicopter fleets worldwide, Boeing was already looking ahead. In May 2019, the company tested a compound Apache scale model in a wind tunnel. This design included a pusher propeller, a small wing for extended range and speed, and a counter-torque tail rotor reminiscent of the canceled Lockheed AH-56 Cheyenne from the 1960s. This new concept wasn't just an experiment. It was Boeing's contender for the U.S. Army's Future Long-Range Assault Aircraft program, unveiled in April 2019. Developed as part of the Future Vertical Lift Capability Set 3 initiative, the FLRAA aimed to create a medium-lift rotorcraft without an attack-specific requirement. Meanwhile, the Army's Future Attack Reconnaissance Aircraft program sought to replace the retired Bell OH-58 Kiowa and potentially half of the AH-64 Apache fleet. The Apache today. Fast forward to 2024, and the Apache is still in production, now in its most advanced form, the AH-64E Guardian. Boeing is producing these helicopters at an economical rate of 82 aircraft per year. The company has stated that the minimum sustainment rate for production is 48 helicopters annually, while current tooling and factory space could handle up to 98 per year. With additional investment and labor, production could even surge to 144 helicopters annually if needed to meet demand. With its unmatched firepower, cutting-edge technology, and proven survivability, the AH-64 Apache has earned its title as the most feared helicopter in the U.S. Army's arsenal. That's the story of the AH-64 Apache, a machine that continues to shape the future of combat. If you enjoyed this deep dive into one of the most iconic helicopters ever built, make sure to like, subscribe, and comment below.